What is a quadratic function? These dancing graphs are all parabolas or quadratic curves. They differ in height, depth, width, position, and whether they open upwards or downwards. And yet they all have the same basic features. In this lesson, we shall explore the features of quadratic graphs and how to create variations. We shall also practice how to sketch a quadratic curve. Welcome. Let's start with a graph of y is equal to x squared. This parabola or U-shaped curve is the most basic form of a quadratic function. The term with x squared is the most basic feature in a quadratic function. In this specific instance, the lowest point of the quadratic graph is a point 0, 0, and the graph curves endlessly upwards to infinity. It has only one line of symmetry. This line is also called the axis of symmetry. In this case, the axis of symmetry is the y-axis on the line x is equal to 0. And 0, 0 is the vertex or turning point, also called the minimum point. We shall now put a number in front of x squared and see how this number affects the curve. This number a is called the leading coefficient and is commonly represented by the letter a. When the value of a is equal to 1, the curve remains exactly as it was before. In algebra, a coefficient of 1 in front of a variable is usually not written. See how the curve shrinks inwards as we increase a, and how it stretches outwards horizontally as we decrease a. By varying a, we can change how steeply the parabola rises or falls. A high value of a makes the curve rise more steeply, so it's narrow. But the opposite is the case for low values of a. What if we have a negative value of a? Just watch this. Notice the dramatic change of the curve when we change a to a negative number. When a is positive, the parabola opens upwards, and the vertex is its lowest point or the minimum point. But when a is negative, the parabola opens downwards, and the vertex is its highest point or a maximum. In summary, the width of the curve depends on how big a is, and the direction of the curve depends on the sign of a. This is exciting stuff, but we can have even more drama by bringing in a new actor. Let's introduce a second term, bx. Bx is a linear term because it contains x to power 1. B can be 0, positive, or negative. When b is 0, the symmetry of the curve is on the y-axis. The line x is equal to 0. Increasing b from 0 shifts the symmetry of the parabola to the left. Conversely, reducing the value of b from 0 shifts the symmetry of the curve to the right. Don't worry about the vertical shift of the curve for the time being. This will be explained a little later. For the time being, just focus on how the value of b affects the horizontal position of the axis of symmetry. Well, it's worth observing that the axis of symmetry is affected by both the values of a and b. Here is a quick way to determine the equation of the axis of symmetry. It is a line given by x is equal to negative b over 2a. For example, with b equals negative 4 and a is equal to 2, so negative 4 is positive 4 divided by 2 times 2, you get x is equal to 1, and that is the axis of symmetry. If you change a back to 1, the axis of symmetry shifts to x is equal to 2 because negative 4 is 4 divided by 2 times 1, which is simply 4 divided by 2. X is equal to 2. Note that if a is 0, the term with x squared disappears. And so we no longer have a quadratic function. What we have now is a straight line, a linear function, and b is the gradient. Key point to note: in a quadratic function, the leading coefficient a should never be equal to 0. Are you still following the story? I hope it's all making sense. Just one final actor now. We now introduce c, a constant term, to the right side of the expression. It now reads y is equal to ax squared plus bx plus c. C is just a number, a constant without x. C can be positive, negative, or even 0. When it is 0, c makes absolutely no difference to the original curve. Increasing c shifts the curve vertically upwards, and decreasing c shifts the curve downwards. The actual role of c becomes immediately clear as soon as we shift the vertex from the y-axis. Specifically, c is the y-intercept of the curve, where it crosses the y-axis. When c is equal to 3, the y-intercept is a point 0, 3. Once c is set, we can shrink or stretch the curve by adjusting the value of a, or even shift the vertex by changing b, but the y-intercept remains locked at the point 0, c, in this case 0, 3. This is the reason the curve seems to shift vertically as we vary b, because c remains fixed while every other point of the curve is affected by the value of a or b. Let us now talk about the roots of a quadratic. The roots of a quadratic is a point where the parabola cuts the x-axis. We shall look at 3 different possibilities. Case 1. The parabola exists exclusively above or below the x-axis. Since the curve has no points on the x-axis, we have no roots. Case 2. The vertex is a point on the x-axis. This then is the only root of the function. The root is the x-coordinate of the vertex. Case 3. The curve crosses the x-axis at 2 points, this one and this one. This gives us 2 distinct roots. The roots are the x-coordinates of the intersection points, and they are shown here. The 2 roots are commonly referred to as alpha and beta. When you are required to solve an equation in the form y is equal to 0 or f of x is equal to 0, they expect you to find the roots of the curve. In other words, find the value or values of x when f of x is equal to 0. That is, when the curve crosses the x-axis. This can be done graphically, as already demonstrated. But there are other methods of solving a quadratic equation. We shall learn these in our next video. Let's wrap it all up by looking at the standard form of the quadratic function. When expressed in the standard form, a, b, and c must be integers, but a should never be equal to 0. It is now time to practice what we have learned by sketching a quadratic function. Here is an example. Sketch the graph of y is equal to negative x squared plus 3x plus 4. We start by finding the roots. So we have negative x squared plus 3x plus 4 is equal to 0. If we multiply by a negative 1, we can rewrite this in a more convenient form. X squared minus 3x minus 4 is equal to 0. Then we factorize the left-hand side and we get the factors x plus 1 times x minus 4 equals 0. This leads to the root x plus 1 is equal to 0, which means that x is equal to negative 1. This means that the point negative 1, 0 is on the curve, is one of the roots. Remember, the y value is 0 at any root. Equating the other factor to 0, we get x equals 4 as our second root. So the point 4, 0 is also part of the curve. Next, we need to determine the axis of symmetry and plot the vertex. The axis of symmetry is a vertical line which passes exactly halfway between the two roots. We can find a point halfway between the roots by adding the x coordinates and dividing by 2, and we get the point 1.5. This is the midway point between the two roots. So x is equal to 1.5 is the axis of symmetry. Or we could have used the equation negative b over 2a. Here is the axis of symmetry. The line x is equal to 1.5. Now let's look at the equation again. We note that the leading coefficient is negative. That tells us that the curve opens downwards and the vertex will be a maximum point. Since the vertex lies on the line of symmetry, the x-coordinate is 1.5. We can find the y-coordinate by substituting 1.5 for x in the given equation. Once we do that, we get y is equal to 6.25. So our vertex is the point 1.5, 6.25, and we plot it. We now have 3 points. Since the y-intercept is the value of c, in this case 4, we shall now plot the point 0, 4, this one here. Using symmetry, we know there must be a corresponding point a similar distance to the right of the axis of symmetry, 1.5 units from the axis of symmetry. On the right side, we have the point 3, 4. We now have 5 points. All we need to do is join them as smoothly as possible to complete our sketch. That's the quickest way to plot a parabola using only 5 points. In our next video, we shall teach you 5 different methods of solving quadratic equations. See you then.
Watch the next video. Share with a friend. Subscribe and hit the notification bell icon. Thank you for watching.